First, we insert the rocket motor and load the UAV.
The rocket is moved to the pad. Time for pre-flight checks.
The rocket is armed and we do a final telemetry check.
I think there's a countdown?
There's definitely a countdown.
3, 2, 1. Burning up $200 worth of ammonium perchlorate.
Soaring all the way up to 8,000 and some odd feet.
At apogee, the drone deploys and the nose cone opens up,
Exposing the payload and giving us an eye in the sky.
Things fall for a while.
Then the drone deploys whenever we choose.
The autonomous navigation begins.
Plane circles the target, spiraling down, but we're on the clock.
The pilot will determine the final approach.
And assuming all of that goes as planned,
We land right on target like a bunch of professionals.
I'm the president of Cougar Rockets. We started this year with 2 members on campus, but in the last 7 months, I've worked to develop and maintain the membership with enough expertise to tackle the complex and multidisciplinary systems required for a competition like the Argonia Cup.
I oversee the rocket construction for the competition. We went with a fiberglass construction for this. Originally, we had planned on a 4-inch diameter, but the altitude gains were too great with a 3-inch diameter, so that just kind of became a problem for the drone team to deal with. We have 2 motors in mind for the rocket, one being the K270, which is a nice long burn for maximum altitude. But if the wind is really blowing, we're going to have to go with a K480 because it's a little bit punchier and will keep us closer to the pad.
I'm the lead designer of the payload recovery system. We decided to go with a tube-launched UAV similar to the UAVs developed by Lockheed Martin and Raytheon. The UAV is a semi-autonomous aircraft with a pusher-style motor setup with deployable wings. I personally worked on the 3D modeling of the frame, the main wing deployment, and the FPV system, and the shell.
I'm Ryan, and I'm part of the design team, and I mainly worked with the rocket, designing a mechanism for the glider to be able to clear the rocket properly when it is released from the rocket. And I've been working with the iterative design process in order to come up with a reasonable and effective means of developing this hinge.
As a part of the design team working on the UAV, one of the major challenges was space. The rear of the UAV is made up of a deployable V-wing, a folding push propeller, and a release mechanism to drop the UAV out of the rocket tube. It's a lot of moving parts in a small space. We chose to use a V-wing as it is more compact when placed in the rocket tube, and then when it's deployed it has the traditional control of a rather regular rear plane wing. Moving the propeller and the motor to the back gave us a lot more room at the front for a clear view for the FPV system and really made our design rather unique. I think we have an interesting concept and I think it'll be good.
I am in charge of the autonomous navigation systems for the glider. So navigating the plane once it's launched out of the rocket is a pretty serious engineering and design issue. So it's not like a traditional, when you launch a RC plane from the ground, you know what parameters it's going to encounter. Whereas once you're up in the air and then you drop it, you don't really know what it's going to encounter. So to reduce the amount of potential human error in the system, we are going to attempt to autonomize as much as we can using open source hardware. So this includes using everything from sensors, GPS systems, autopilot, etc.
As part of the payload delivery team, I focused on sensor integration. We have a couple sensors here. First, the airspeed sensor. It will give us an accurate reading on our airspeed velocity throughout the flight. We also have the ultrasonic sensor. It essentially uses echolocation to help us smooth out our landing process and other processes along the way.
We expect the rocket to reach apogee about 9,500 feet.
The rocket's going to go about 2,800 meters.
On board the rocket is the Altus Telemetrum, and then the Easy Mini.
On the glider, we have a Pixhawk 4 for the autopilot system, along with various long-range modules for transmitters and receivers so we can get constant data from the glider.
I would say the relationships I've formed, the people in the club are all pretty awesome, and I have a great time showing up at meetings.
I think I've been in Cougar Rockets for quite some time, since it started, and I like to see it develop into what it is right now, because we definitely started from a strange place, and we've definitely progressed to a very worthwhile and fun experience. So.
I'm just happy to be here.
Oh, I think we're gonna win for sure.
I think we got a good chance. Our design is pretty good. We've ran a bunch of simulations, so I think we got a good chance.
Just going and competing for me is a win.